Hello there, and welcome to the Sleep Science Space. I'm really glad you've wandered in. Maybe today has been long, or maybe you're the kind of person who drifts off more easily when your mind has something vast and beautiful to rest on. Either way, tonight, you don't have to do anything at all. Just settle in, feel your breathing slow, and let your body grow light as though gravity itself has softened its hold on you. Because this evening, we're not simply looking at the stars, we're gliding through our home galaxy, the Milky Way, an immense spiral of dust stars and dark matter that has been turning gently in space for more than 13 billion years. Beneath that soft glow in the sky lies a world of hidden stories, wandering rogue stars, forces we cannot see, and ancient remnants that rewrite what we thought we understood. Tonight we'll travel quietly from the spiral arms to the shadowed galactic core, through stellar nurseries and the ruins of cosmic collisions, meeting stars older than the galaxy that holds them. Some of these ideas may surprise you or simply spark a warm thread of curiosity as you drift toward sleep. And before we lift off, if these calm explorations help you unwind, a like or a gentle tap on subscribe helps other sleepy travelers find their way here too. Now let's begin. The Milky Way. You see above you is not as still as it seems. It has collided with other galaxies before, and it will do so again. Our galaxy feels like a steady home, yet it was built from the remnants of others pulled in over billions of years. Small galaxies have been stretched apart, their stars unraveling into long tidal streams that wrap like faint ribbons around the galactic disk. One of them, the Sagittarius dwarf galaxy, is being torn open even now, and far across the sky, the Andromeda galaxy is drifting toward us. In about 4.5 billion years, the two spirals will blend in a slow, immense merger. Their stars will rarely collide, but their shapes will dissolve and reform into something new and quiet. Even galaxies have life cycles. They grow, collide, and begin again. And some of the stars inside the Milky Way are older than the Milky Way itself. Not every star was born here. High above the galactic plane wander ancient metal-poor halo stars, objects that likely formed before the Milky Way fully assembled. Their chemical signatures contain almost no heavy elements, marking them as survivors from a time just after the Big Bang, when the universe was raw and almost entirely hydrogen and helium. These stars drift in long, arcing orbits like elder witnesses from an age before spiral arms existed. In their faint light, we glimpse a younger, wilder universe, still learning how to organize itself into galaxies. And through all of this, our own solar system is not sitting still. It races around the Milky Way's center at more than 828,000 kilometers per hour, about 230 kilometers every second. Even at that speed, one complete orbit around the galaxy, a single galactic year, takes roughly 225 million Earth years. In the entire history of our solar system, we've completed only about 20 of those vast cosmic loops. When the first dinosaurs roamed Earth, we were in a completely different region of the galaxy. The stars we see above us tonight were not always neighbors, and they will not remain where they are now. Everything in the cosmos is drifting quietly, steadily, without pause. Even as we sleep, Earth keeps turning, the moon traces its endless loop, and the entire solar system moves forward through a galaxy that is never truly still. And the Milky Way itself is still growing. Though ancient, it has not finished forming. Even now, it continues to draw in new material, gas drifting between galaxies, stars stripped from passing dwarfs, and faint rivers of dark matter feeding its halo. Some of this growth happens softly through slow infall. Other times, it comes through disruption as smaller galaxies are torn apart and their stars stretched into long streams across the sky. The Milky Way you live in today is not the same one that arched over the dinosaurs. And far in the future, the galaxy your descendants inherit may be larger, still built from the remains of countless smaller worlds. And surprisingly, we still don't know exactly how many spiral arms the Milky Way has. It seems like something that should be simple to count, yet, from our vantage point inside the disk, the structure becomes difficult to see. Dust clouds block our view. Stars overlap into shimmering fog. For years, astronomers thought there were four major arms. More recent observations hint at fewer or at a pattern far more complex, with arms that branch, twist, fade, or curl back into themselves. The Milky Way may not be a tidy pinwheel at all, but a layered, shifting swirl carved by forces we do not yet completely grasp. Deep within this structure, most stars travel calmly around the galactic center, but a few break the pattern dramatically. Some stars are flung outward at astonishing speeds, fast enough to escape the Milky Way entirely. These hypervelocity stars often come from binary systems torn apart by the supermassive black hole at the galaxy's heart. One star is swallowed, the other is fired outward, like a cosmic arrow racing alone into intergalactic space at more than 1,000,000 kilometers per hour. They drift far above the galactic plane, solitary and silent reminders that even in a universe governed by gravity, there are moments when stars are cast loose into the dark. Meanwhile, another vast motion unfolds across the sky. The Andromeda Galaxy, visible from Earth as a pale smudge, lies more than 2 million light years away, yet it is moving slowly toward us. In roughly 4.5 billion years, Andromeda and the Milky Way will come together. The collision will not be a sudden crash. Stars are far too spread out. Instead, the two spirals will stretch and distort, drawing out great tidal tails. Their central black holes may spiral toward one another, and over billions of years, the galaxies will settle into a single, larger structure. A quiet transformation written in the long language of gravity. Even now, clues to past interactions surround us. Most stars in the Milky Way orbit the center in the same general direction, but some do not. A handful, especially those in the outer halo, move in retrograde, circling opposite the galaxy's rotation. These stars are likely remnants of ancient mergers, pieces of long-lost galaxies that were absorbed and blended into the Milky Way long ago. These backward-moving stars most likely came from somewhere else, born inside small companion galaxies that drifted too close and were gradually swallowed by the Milky Way. Their reversed paths are like quiet signatures of a distant origin, tiny motions revealing stories older than our spiral arms. It's as if the galaxy remembers its past, not in words, but in orbits. Each unusual trajectory marks a moment when another world brushed against ours and disappeared into its glow. And over time, the Milky Way has consumed many such companions. For billions of years, it has grown not only by forming new stars, but by absorbing entire dwarf galaxies that wandered too near. Some were faint and ghost like. Others, like the Gaia Enceladus system, were large enough to reshape the young Milky Way when they merged. Their stars now drift through our halo, our disk, and through delicate arcs wrapped around the galaxy. The Milky Way is not a pristine spiral. It is a mosaic pieced together from quiet collisions and the long, slow blending of smaller stellar families. One of the most remarkable tools we have for uncovering this hidden history is chemistry. Every star is born with a distinct mixture of elements, a chemical fingerprint that reveals the environment where it formed. Some have rich layers of iron magnesium or calcium, showing they were born in later metal rich regions. Others contain almost only hydrogen and helium, evidence of origins in the universe's early unpolluted eras. By studying these elemental patterns, astronomers can trace which stars share a common past, untangle ancient mergers, and piece together the Milky Way's earliest chapters. Chemistry, in a way, becomes a soft lantern shining backward through time, and the sky is full of reminders. Stretching across space are thin, graceful ribbons of stars, stellar streams left behind by dwarf galaxies torn apart by our own. These streams loop around the Milky Way like pale threads shaped by tidal forces that gently pulled their parent galaxies apart. Some sweep across the halo in broad arcs. Others fall inward, spiraling toward the core. They are the fossil trails of vanished worlds, faint and fragile, but still visible to those who know where to look. Even the galaxy's shape carries the imprint of these encounters. The Milky Way's disk is not perfectly flat. Instead, it bends upward on one side and dips on the other, forming a slow, elegant wave that ripples across its stars. This warp remained hidden until radio telescopes traced hydrogen gas far beyond the visible disk. The distortion may be caused by nearby satellite galaxies tugging softly on our edges, or perhaps by uneven clouds of dark matter lifting and lowering sections of the disk. Whatever the cause, the warp reminds us that even giant galaxies bend to unseen forces. They flex, breathe, and shift form over cosmic time. Viewed from afar, the Milky Way might look like a spinning ribbon gently twisting in space, a spiral leaning into its own quiet dance. And yet from Earth under the clearest sky, you can see only the faintest hint of this enormity. With the naked eye far from any city lights, you might notice a few thousand stars glittering, countless to us, but in truth only a vanishing fraction of what surrounds us. Less than 100 millionth of the Milky Way is visible to human eyes. The rest lies wrapped in dust, hidden by distance or simply too faint for us to perceive. Still, even this small portion is enough to remind us that we are drifting inside something vast, layered, and ancient. a galaxy shaped by mergers, enriched by stellar generations, and held together by gravity's quiet, patient hand. Most of the galaxy is hidden from us. Some regions sit behind dense curtains of dust, others lie too faint or too distant for human eyes to ever perceive. The pale milky band we see stretching across a moonless sky is only the thinnest whisper of the whole, just the inner glow of a structure so enormous that we can barely imagine it from where we stand. We live inside a vast river of starlight, yet almost all of its brilliance remains beyond our reach, veiled by distance and shadow. And within that great river, every star is moving. Unlike planets circling a single star in tidy, predictable loops, the stars of the Milky Way wander along more complicated paths. Those near the center rush ahead, those toward the outer rim drift more slowly. This difference in speed is what creates the illusion of spiral arms. They're not rigid structures at all, but waves, slow moving traffic patterns of stars and gas winding through the galaxy. As these waves sweep past, they compress giant clouds of material and ignite waves of starbirth, lighting the arms in shimmering curls of blue and white. Our sun drifts through these patterns, rising and falling through the galaxy like a leaf carried on a current. The Milky Way is not a precise clockwork machine. It is a flow, a motion, a long tidal drift of stars. And holding this drifting structure together is something we still cannot see. By all ordinary calculations, the outer regions of the galaxy spin far too quickly. With only the visible stars, dust, and gas, the Milky Way should fly apart like sparks shaken from a wheel. Yet it doesn't. Something unseen binds it, something massive, something silent. That something is dark matter. It doesn't radiate, reflect, or glow, but its gravity outweighs all the luminous matter combined. Without it, the galaxy would unravel. With it, the Milky Way holds its shape, an invisible framework cradling billions of suns. We still don't know what dark matter truly is, only that the galaxy depends on its unseen pull. At the very center of this structure lies something even stranger. Deep in the core, buried behind dust and gas, sits a supermassive black hole known as Sagittarius A. It carries the mass of more than 4 million suns, yet occupies a region smaller than Mercury's orbit. We cannot watch it directly, but we've seen stars whip around it in tight, rapid arcs, tracing its gravity like invisible ink. From time to time, a cloud of gas falls inward and briefly ignites in X ray light before vanishing beyond the event horizon. For now, Sagittarius A rests quietly. Long ago, it may have roared as a quasar bathing the galaxy in radiation. Today, it moves softly, guiding the slow swirl of the Milky Way's heart. And that heart is not smooth. When astronomers mapped the inner region, they found the bulge of stars forming a curious three-dimensional shape, something like a gently twisted peanut or an hourglass. This unusual geometry likely arose from the galaxy's central bar, a concentrated line of stars rotating through the core. Over billions of years, that bar buckled and lifted, creating a thickened, sculpted center shaped by the push and pull of countless orbits. We call our home a spiral galaxy, but its center is far from simple. It is layered, rippled, and alive with motion, and the spiral arms themselves are more than just starry pathways. They are cradles of creation. Immense clouds of hydrogen and dust drift lazily through the galaxy. When these clouds encounter a spiral arm, they're compressed and awakened, triggering fresh waves of star formation. These stellar nurseries glow with newborn suns, their ultraviolet light illuminating the surrounding gases and painting the arms in luminous blues and silvers. These bursts of starbirth trace the galaxy's spiral arms like glowing brushstrokes, outlining each curve with quiet, shimmering fire. Every star you've ever seen, including our own sun, once formed inside one of these misty cradles. And far beyond those bright coils of the disk lies something even more mysterious, a vast, nearly invisible halo that surrounds the entire Milky Way. Out there, above and below the spiral, the galaxy stretches into a faint sphere of ancient stars, dark matter, and long forgotten remnants of cosmic encounters. This halo is incredibly diffuse, yet astonishingly massive. Most of the Milky Way's weight may actually sit here, spread across emptiness, so thin we can barely detect it. Stars in the halo drift along enormous orbits, taking hundreds of millions of years to loop once around the center. Many of them arrived from other galaxies, torn free during ancient mergers, and now preserved as delicate arcs and streams, fossils of collisions long past. This region is the galaxy's outer memory, dim, quiet, and old. Within it float more than 150 globular clusters, compact spherical hives of starlight. Each cluster holds hundreds of thousands of stars, packed tightly together, orbiting the galaxy, like lanterns drifting through deep water. Some are more than 12 billion years old. Many formed before the Milky Way itself had fully taken shape. Their stars contain almost no heavy elements, their chemistry frozen from a time when the universe was still young and simple. To astronomers, these clusters are ancient archives, revealing how the galaxy assembled itself, what it consumed, and what the cosmos looked like before spirals even existed. These golden, densely bound spheres drift above and below the disk patient and enduring, and the Milky Way is still changing. Even at this moment, it continues to gather material streams of cold gas from intergalactic space stars drawn from dwarf galaxies and unseen rivers of dark matter flowing into the halo. Sometimes this growth is gentle, like clouds settling into the disk. Other times it's more dramatic, as small galaxies brush too close and are gradually pulled apart, their stars smeared across the sky in long, glowing ribbons. The galaxy you inhabit tonight is not quite the same one the dinosaurs saw, and far in the future, it will grow larger, still stitched together from the remnants of countless smaller worlds. Deep inside this vast structure, most stars follow the slow, steady flow of galactic motion. But a rare few break free. These are rogue stars, hypervelocity travelers flung outward at incredible speeds so fast that they can leave the Milky Way behind entirely. Many come from binary star systems that wandered too close to the supermassive black hole at the galactic center. One star falls inward and disappears. The other is hurled away, slingshotted into darkness at over 1,000,000 kilometers per hour. It drifts alone through intergalactic night, a glowing ember cast out by the galaxy's restless heart. The rotation curve of our galaxy refuses to behave the way Newton's equations say it should. If only the visible matter mattered. Stars, gas, dust. Then the outer regions ought to drift lazily around the center, moving slower and slower the farther they are. But that isn't what we see. Out at the galaxy's edge, stars race along almost as fast as those deep inside the core, as though held by a gravity we cannot see. This strange, stubborn pattern is one of the strongest clues that dark matter exists, a hidden mass forming a vast, invisible halo around the Milky Way. Without it, the galaxy would unravel like a loose spool of starlight, its outer stars flung into the void. Instead, they remain bound, moving in a flat rotation curve that whispers of something immense and unseen cradling the galaxy in a shadowed grip. In that way, the Milky Way's motion is both familiar and mysterious. We recognize the pull of gravity, but not its source. Dark matter keeps the galaxy whole. But even with this invisible support, the Milky Way is not static. It bends and ripples. Our galaxy is subtly warped, its disk not perfectly flat, but tilted upward on one side and dipped on the other. Radio maps of hydrogen gas reveal this gentle twist like a wave frozen in rotation. Something is tugging on it, perhaps the Magellanic Clouds, perhaps clumps of dark matter, perhaps leftover motion from ancient collisions. Whatever the cause, the warp drifts slowly through the galaxy like a soft imbalance, reminding us that even structures as vast as these are still malleable. And all the while, star birth continues, but more quietly now. Long ago, the Milky Way gave rise to stars in great blazing waves. Today, that pace has slowed. The raw material for new suns is thinner, warmer, more difficult to compress. The galaxy isn't finished, but it is settling, moving from a stormy youth into a calmer middle age. A few suns still flare into existence each year, but the frenetic creation of the past has softened into a gentler rhythm. Some stars, though, belong to an age even older than the spiral we see today. Before the disk formed, before the arms twisted outward, before the bar buckled, the galaxy existed as a lumpy collapsing cloud of gas and dark matter. The stars born in that era still wander the halo and thick disk. Their motions are slow, eccentric, and untamed. Their chemical fingerprints reveal nearly pristine compositions, untouched by generations of stellar evolution. These are the galaxy's elders, silent travelers that watch the Milky Way condense, flatten, and spin itself into the spiral we now call home. And like every star, our sun is part of a far greater journey. A galactic year, the time it takes the solar system to orbit once around the Milky Way, lasts between 225 and 250 million Earth years. Entire continents shift while we make that single lap. Species appear, flourish, and vanish. Entire eras of life bloom and end. In its entire 4.6 billion year lifetime, the Sun has completed fewer than 25 circuits around the galaxy. a surprisingly small number for such a vast stretch of time. We are still newcomers, drifting through an ancient spiral, only beginning our journey compared to elder suns that have orbited hundreds of times. This slow revolution is the galaxy's heartbeat, a rhythm so long and quiet we cannot feel it, yet it carries us along endlessly. And so, when Newton's predictions break at the galaxy's edge and stars refuse to slow down, it invites a deeper realization: the Milky Way is held together by something far larger, far stranger than the light we see. Its structure, its rotation, its very silhouette in the cosmos, all shaped by gravity that glows with no light. A reminder that in the universe, the unseen often guides everything we know. The reason astronomers believe is dark matter, a silent, invisible mass that surrounds the Milky Way in a vast, ghostly halo. Without it, the galaxy would unravel. With it, the numbers finally make sense. The Milky Way rotates almost like a solid wheel, not because we fully grasp the mechanism, but because something unseen is holding everything together in its quiet gravitational embrace. And scattered within this turning structure lie some of the most hauntingly beautiful objects in the galaxy: enormous molecular clouds. These great cold reservoirs of gas, mostly molecular hydrogen, with tiny specks of dust, stretch across hundreds of light years. Inside them, temperatures fall so low that light itself struggles to escape. To our eyes, they appear as dark voids, patches where stars should be, but are not. Yet, within those shadows, future suns are gathering. Gravity nudges the gas inward, forming denser and denser knots. Deep inside, invisible to human sight, the earliest moments of starbirth begin in absolute silence. These clouds are the galaxy's hidden wombs, quiet chambers, where new worlds are conceived behind curtains of dust. And while these nurseries sleep, supernovae roam the galaxy like cosmic storms. When a massive star dies, it does so in a brilliant, violent flash, a supernova bright enough to outshine an entire galaxy for a heartbeat in cosmic time. But these explosions are not merely endings, they are beginnings. The shock waves they unleash ripple outward, compressing nearby clouds, lighting the fuse for new star formation. They scatter heavy elements, iron, gold, calcium elements, forged deep within their cores, spreading them across the galaxy like seeds. In this way, supernovae churn the Milky Way, stirring, enriching, and renewing it. Destructive and creative, they are the storms that keep the galaxy alive. But much of this drama remains hidden behind interstellar dust. Thin grains of carbon, silicate, and ice drift through the Milky Way, woven into filaments and clouds. In visible light, this dust blocks entire regions of the sky, swallowing starlight and making enormous stretches of the galaxy appear empty. But those dark patches are rarely empty. Infrared telescopes reveal the truth. Glowing star nurseries, clusters of newborn suns, delicate jets streaming from protostars. What looks like darkness is often the beginning of something bright, and not all gas becomes a star. Some clouds drift in near perfect stillness, cold, heavy with hydrogen, yet untouched by fusion. These starless clouds wander through the galaxy like unfulfilled potential. Perhaps they are too diffuse. Perhaps magnetic fields hold them apart. Perhaps turbulence keeps collapse at bay. They are possibilities waiting for a push, a passing shock wave, a collision, a ripple of gravity. Until then, they roam as quiet reservoirs of material, future stars held in suspension. Because the Milky Way is a master of recycling. Every generation of stars enriches the next. Old stars die scattering metals into space. New stars ignite within those ashes. Planets form from the leftover dust. Life, at least on Earth, emerges from this long chain of cosmic renewal. Even now, atoms in your body, iron in your blood, calcium in your bones, oxygen in your lungs were forged in long vanished stars and spread across the galaxy by ancient explosions. The Milky Way remembers its history, not through words, but through matter. What has died becomes the material for what will be. And so the galaxy continues a quiet cycle of creation and dissolution playing out over billions of years. Stars, for all their brilliance, are temporary. They ignite, they shine, and eventually they fade. But their endings are not truly endings. When a star dies, it gives itself back to the galaxy. Supernovae scatter heavy elements across space. Red giants peel off their outer layers like petals drifting in a cosmic breeze. Planetary nebulae expand outward in soft, colorful shells. All of this enriched material returns to the interstellar medium where it cools, settles, and gradually gathers into new clouds. From those clouds, new stars form, new planets form, and eventually life itself emerges. Every atom in your body, every calcium atom in your bones, every oxygen atom in your breath has been through this cycle. Born in fire, cast into darkness, reborn in new forms. The Milky Way is not a still backdrop. It is a vast breathing organism of motion and renewal, always reshaping itself through the lives and deaths of its stars. Some of the most ancient clues to this history lie in metal-poor stars. In astronomy, metals mean anything heavier than helium. The very first stars had almost none of these elements. They were pure hydrogen and helium forged in a universe still young. Today, astronomers search the halo of the Milky Way for these extremely old metal-poor stars. They are faint, wandering relics from a time before the galaxy fully formed. By studying their composition, scientists can trace conditions from just after the Big Bang, long before spirals existed, before the galaxy found its shape. They are fossils not carved in stone, but in starlight. And the stars we see today aren't always where they began. A star's birthplace rarely determines where it will spend its life. Over millions of years, stellar orbits shift. Gravity nudges them. Encounters with other stars redirect them. The spiral arms themselves exert subtle pulls, pushing some stars outward and drawing others inward. A few are launched at extraordinary speeds, ejected from clusters or slingshot by massive objects sent drifting across the galaxy or into the halo. Even our own sun is a traveler far from where it once formed. The Milky Way is a place of migration, not stillness. Stars wander, paths evolve. A home in the galaxy is rarely permanent. Astronomers even suspect the galaxy has its own habitable zone, a vast region where conditions may be just right for life. Closer to the center, radiation floods space, and gravitational tides are chaotic. Farther out, the abundance of heavy elements drops, making it harder for rocky planets to form. Somewhere in between lies a gentle, stable band of star systems with enough ingredients for oceans, atmospheres, and living worlds. Earth sits within this quiet middle ground, one small orbit in a region where life might find the balance it needs. Even the spiral arms, those grand shapes we imagine stretching across the disk, are not built from fixed stars. They are patterns, not structures, waves of density that move through the disk, compressing gas as they pass. Stars drift and glow for a time, then drift back out. The arms rotate at a different speed than the stars themselves, like a slow moving traffic wave passing through a busy highway. From inside the galaxy, it looks like order. From above, it is motion layered upon motion. And beneath all this, the galaxy hums with invisible energy. Cosmic rays, high energy particles from supernovae and distant galaxies stream constantly through space, passing through you even as you listen. X rays flare from collapsing stars. Gamma rays whisper from black holes and exotic remnants. The Milky Way glows at frequencies our eyes cannot see, a silent orchestra of radiation flowing through the dark. Radio waves drift through the galaxy like quiet whispers coming from cold hydrogen clouds, from the rhythmic beating of pulsars, and from the faint breath of distant gas. These invisible frequencies reveal things starlight cannot: turbulence, magnetism, ancient explosions, and the lingering warmth of events long faded. When you look up at the night sky, you're seeing only the thinnest sliver of the Milky Way's true spectrum. Beneath that sprinkle of visible stars, the galaxy is glowing in many wavelengths at once, a hidden symphony humming softly in the dark. High above and below the galactic center stretch two enormous lobes of gamma light. These are the Fermi bubbles, vast ghost-like structures extending tens of thousands of light years from the core. They glow in energies far beyond human sight, their origins still mysterious. Some astronomers think they are relics of a long past eruption from the central black hole. Others believe they mark the aftermath of an intense burst of star formation that once lit the core like a furnace. Whatever their cause, the bubbles hang silently above the galaxy, radiant, ancient, and invisible to the naked eye. They are reminders that the Milky Way carries scars from ages we can no longer witness. Our solar system rests not in a major spiral arm, but in a smaller feature called the Orion Spur, a gentle, quieter lane between the larger Sagittarius and Perseus arms. It's a peaceful neighborhood, neither too dense nor too chaotic. And perhaps that calm is why life had the time it needed to grow on Earth, far from the heavy traffic of massive stars and frequent supernovae. This little spur offered a soft pocket of stability within a dramatic galaxy. At the center of the Milky Way, infrared eyes reveal a long, glowing bar of stars stretching across the core, a bright rotating structure that stirs the inner galaxy. This central bar acts like a gravitational engine, nudging gas inward, shaping the spiral arms, and slowly feeding material toward the supermassive black hole. Bars like this are common forming when stars migrate inward and settle along a shared axis. Over time, this bar becomes a dominant feature, sculpting the galaxy's inner regions and directing the flow of stellar birth and motion. And beyond all of this, the Milky Way itself belongs to something larger, a quiet cosmic neighborhood called the Local Group, a cluster of over 50 galaxies drifting together through intergalactic space. Its two giants, the Milky Way and Andromeda, anchor this family. Around them orbit clouds of smaller galaxies, dim dwarfs, elongated ellipticals, and tiny star-poor systems made mostly of dark matter. The local group stretches across more than 10 million light years, held together not by closeness, but by gravity, an invisible network binding every member in shared motion. Despite the vast distances between them, these galaxies are not drifting apart. Many are slowly moving toward one another, caught in a long, slow gravitational dance. Small dwarf galaxies loop around the Milky Way, like satellites, some gradually torn apart into streams. Others roam independently, but remain tethered to the group's collective pull. Over immense periods of time, this cluster may tighten its members, spiraling ever closer as gravity patiently reshapes their shared future. Galaxies may drift toward one another, merge, dissolve, or quietly vanish into larger systems. Nothing in the universe stays arranged forever. Instead, everything slowly gathers, joins, or fades. Cosmic islands, drawn together by time inertia and the unending pull of gravity. The Milky Way's disk, which looks smooth and flat from far away, is actually layered when seen closely. We live in the thin disk, a broad plain crowded with young stars, open clusters, drifting nebulae, and the gas that sparks new stellar birth. Above and below it lies the thick disk, a more ancient structure. Its stars are older, poorer in heavy elements, and move in higher, more tilted orbits. They belong to an era when the galaxy was still unsettled, shaken by collisions, stirred by mergers, shaped by forces no longer present. The disk is not a single sheet. It is textured and stratified like sediments layered over billions of years at the bottom of a cosmic sea. Threaded through this entire structure is something we cannot see, a vast magnetic field stretching across the disk, arching into the halo, and weaving through the interstellar medium. Though faint compared to anything on Earth over galactic distances, these magnetic lines influence everything: how gas collapses into stars, how cosmic rays travel, how matter flows from arm to arm. They curve along the spiral structure, climb into great arcs above the plane, and twist into loops that still puzzle astronomers. We detect them only through radio observations, through polarized light, through the faint way they steer charged particles. The Milky Way is not just a river of starlight, it breathes a magnetic rhythm through its very bones. Between the stars lies the interstellar medium, an almost invisible mixture of gas dust and plasma. To human eyes, it seems like emptiness, but under radio and infrared light, it becomes a world of structure, filaments stretching for light years, shock fronts carved by supernova bubbles, hollowed out by stellar winds, and cold, dense clouds where new stars gather in silence. This medium is not a void. It is the living fabric of the galaxy stirring, cooling, collapsing, and reshaping itself endlessly. Through this medium stream, cosmic rays, high energy particles launched by ancient supernova long before Earth existed. Every second they pass through your body without a sound, traveling near the speed of light, spiraling along magnetic fields, striking atoms in Earth's atmosphere, and creating showers of secondary particles. We don't feel them yet, they are everywhere, tiny messengers from violent events scattered across the Milky Way. Even as you rest, the galaxy is speaking softly through these particles, through invisible rays, through energy older than our planet. And despite the neat diagrams often drawn in textbooks, the Milky Way is not perfectly symmetrical. Its spiral arms are uneven, its disk is warped, its stars move with a subtle tilt. The galaxy breathes and bends, shaped by invisible matter, ancient collisions, and the quiet gravitational pull of its surroundings. It is not a flawless as pinwheel, it is a living structure, shifting slowly through time, carrying the memory of everything it has survived. One side of the galactic disk rises higher than the other. Some spiral arms flare brighter or curl more sharply. The warp at the edge of the Milky Way tilts unevenly. Even the number of stars on opposite sides of the sky doesn't match perfectly. These asymmetries likely trace back to ancient gravitational encounters, past mergers passing dwarfs, or the quiet shaping hand of dark matter. Galaxies, much like living organisms, carry the marks of everything they've endured. Their curves and bends are scars of collisions, wrinkles left by time evidence of slow, uneven growth that gives each one a unique identity. High above the plane of the Milky Way, drifting through the quiet halo, astronomers found a star that may be nearly as old as time itself. It contains almost no heavy elements, an unmistakable sign of a star born shortly after the Big Bang, long before the Milky Way finished forming. It glows faintly now, a small red ember low in mass, but immense in memory. It is not merely a star, but a relic from the universe's earliest dawn, carrying in its light the story of an age we can never witness. Closer to the center of the galaxy, the rhythm changes. Stars there orbit far faster than those in the outskirts. The core is dense, packed with dust stars, and the immense gravity of Sagittarius A, the central supermassive black hole. Here, stars whip around the center in only a few million years, tracing tight, rapid loops. Farther out, where our sun lives, the journey is slower, stretching across hundreds of millions of years. This uneven spin twists the spiral arms and keeps the disk from rotating like a rigid plate. The Milky Way behaves like a great turning wheel, one whose heart spins swiftly while its rim drifts behind. The spiral arms themselves are not fixed pathways. They are patterns, waves of higher density sweeping through the disk. When cold gas and dust enter these regions, they compress, collapse, and flare to life as new stars. Those young, brilliant suns brighten the arms briefly, before drifting away while fresh stars ignite behind them. This creates a continuous moving illusion of structure. From afar, the arms look frozen. From within, they are flowing currents carved by gravity's slow choreography. Deep inside the coldest regions of these arms, new stars begin in silence. Vast molecular clouds so cold they hover just above absolute zero float through the dark. Within them, gravity slowly pulls material inward. Dense knots form, spin, flatten, and heat until a protostar flickers at their center. When fusion finally ignites, another sun is born. From the darkest cold comes the brightest light, shaped gently by gravity's patient hand. And many of these newborn stars arrive as families, clusters, bound by the same collapsing cloud. They move together for countless ages, held loosely by their shared gravity. But over time, tides from the Milky Way passing stars and internal motion slowly pull them apart. What began as a tight stellar family gradually dissolves its members, drifting into the wider galactic sea. Stars peel away one at a time until the cluster dissolves into the wider glow of the galaxy. Even our own sun began its life inside such a gathering, born among many siblings that have long since wandered off, some faded, some scattered beyond recognition, others lost completely in the vastness between the stars. Among the treasures hidden within the Milky Way are the ancient hypermetal poor stars, objects of extraordinary rarity. Their atmospheres contain almost no elements heavier than helium. Some hold barely 100,000th of the iron found in our Sun. These stars likely formed shortly after the first supernova seeded the early universe, carrying only the faint signature of those primordial explosions. They are unimaginably old, strikingly pristine, and scattered through the halo like tiny lanterns from the universe's earliest dawn. Each one is a relic, a quiet survivor of an age nearly erased by time. Planets, too, arise throughout the galaxy. They are not cosmic oddities, but a natural byproduct of star formation. When a newborn star ignites, a swirling disk of leftover gas and dust surrounds it. Inside that disk, grains collide, cling together, and gradually accumulate into larger bodies. Across the Milky Way, countless planetary systems take shape, some sprawling with giant planets and icy moons, others compact with rocky worlds orbiting close to faint stars. Some resemble our own, others exist in forms we've barely begun to imagine. The galaxy isn't just full of stars, it's full of families, each with its own architecture and possibilities. Our solar system lies near the corrotation radius of the Milky Way. Here, the average orbital speed of stars matches the pattern speed of the spiral arms. Because of this, the Sun drifts neither quickly ahead of the arms nor falls far behind them. This gentle synchrony may spare us from frequent passages through dense spiral regions where supernovae are more common and gravitational disturbances more intense. By coincidence or fortune, we reside in a relatively calm lane of the galaxy, protected not by boundaries, but by motion itself. As the Sun circles the Milky Way, it also rises and sinks through the galactic plane in a slow, graceful oscillation. Instead of a flat orbit, it follows a vertical sway bobbing above and below the disk over tens of millions of years. This motion comes from the uneven tug of the galaxy's mass lifting and lowering the solar system as it travels. Some scientists have speculated that these vertical cycles might influence extinction patterns on Earth, though the evidence remains uncertain. What is clear is that even in its steady march around the center, the Sun is gently rocking through space, drifting in a cosmic rhythm older than life itself. And through all of this motion, one truth remains unchanged. We still do not know what dark matter is, only that its invisible gravity shapes everything we see. Dark matter composes most of the Milky Way's mass, yet it remains entirely unseen. It emits no light, casts no shadow, and slips through ordinary matter without interaction. But its gravitational pull is unmistakable. It binds the galaxy together, explains why stars orbit far faster than visible mass allows, and shapes the growth of cosmic structures on the largest scales. Without dark matter, the Milky Way would simply unravel. Astronomers detect its presence not by observing it directly, but by watching how it alters the motion of everything around it. It is the hidden framework of the galaxy, silent, invisible, and still one of science's deepest enigmas. Most of the Milky Way's mass lies outside the glowing disk. Though the spiral arms hold the stars we know best, a much larger reservoir of matter surrounds the galaxy. This vast dark matter halo stretches outward far beyond the furthest orbiting suns. Within it drift ancient stars and clusters, but its true substance remains unseen. When we picture the Milky Way, we imagine a glittering disk. Yet the real weight of the galaxy comes from this immense shadow-like halo that wraps around everything. The heart of the Milky Way may once have blazed like a quasar. Today, the core appears faint and quiet, but clues remain of a far more luminous past. The immense gamma ray bubbles found above and below the center, along with high energy echoes in nearby clouds, point to an era when the central black hole consumed matter at a furious rate. Quasars can outshine entire galaxies, and if ours once did, the Milky Way would have glowed around a brilliant central beacon. That chapter has ended, but its fingerprints linger. Galaxies are not fixed portraits, they evolve. Spiral arms shift position, central bars rise and fall. Gas flows inward, then is pushed back out. Stars form age and vanish, slowly changing the population of the disk. Even the shape of the Milky Way, bent and uneven, is gradually reshaped by interactions with passing dwarf galaxies and submerged clumps of dark matter. Over billions of years, the galaxy has changed its outline like a drifting cloud. The Milky Way is beautiful, not because it is still, but because it transforms so quietly. Across the galaxy, gravitational waves ripple through space. Far beyond our sight, massive objects collide black holes, spiraling inward, neutron stars smashing together galaxies, merging in slow cosmic embraces. These events send waves through space-time, faint distortions that pass even through the Milky Way. Though unimaginably subtle, observatories such as LIGO and Virgo have caught their echoes. New experiments seek the soft background hum of these waves crossing the cosmos. Even now, as you listen, space-time shifts ever so slightly, carrying news of distant cataclysms. Not every star follows a tidy, circular path. Many wander along elongated or tilted orbits, looping high above the disk or plunging far below it. These unusual trajectories often reveal their origins remnants of swallowed dwarf galaxies or stars stirred by ancient gravitational upheavals. Their motions are like threads woven through a tapestry, revealing the structure beneath. By tracing them, astronomers map the Milky Way's hidden skeleton of mass and history. These stars drift like quiet survivors of long lost systems, distorted yet still bound to the whole. The Milky Way also floods space with neutrinos. Every second, trillions of these ghost like particles pass through your body, created in nuclear reactions inside stars, in supernova, and in cosmic ray collisions. They rarely interact with matter, slipping through planets and people as if they weren't there. Deep underground and beneath the polar ice, special observatories wait for the rare flash of light that occurs when a neutrino finally strikes an atom. Each one carries a message from places we cannot reach: stellar cores, collapsing giants, and hidden engines of the galaxy. They are the soft murmurs of cosmic fire, and even the space between stars is far from empty. The interstellar medium, a faint mixture of gas, dust, and plasma, is constantly stirred by shock waves, magnetic forces, and drifting stars. It moves like a thin, turbulent sea, shaping and reshaping the environments where new stars will one day be born. Temperatures shift dramatically across the interstellar medium. Streams of gas collide, shear, and break apart. Clouds stretch into filaments, fold into ribbons, and tumble through space. On the scale of the galaxy, this creates a slow, turbulent ocean moving through the disk. Star formation, cosmic rays, and even the Milky Way's long term evolution are shaped by this restless flow. What appears from afar as gentle, steady starlight is up close, a rippling fabric, always shifting under invisible winds and ancient energy. The galactic halo may even hide planets without suns. Not every world remains bound to a star. Some planets are cast out of their systems during early chaos. Others may have formed alone, far from stellar light. These are rogue planets, cold wanderers, drifting through the galaxy, including the outer halo, where stars grow sparse. They travel through darkness with no warmth but the faint heat inside them. Unlit, nearly undetectable, they drift like solitary travelers on endless paths between the stars. Magnetic fields guide the movement of cosmic dust. Tiny grains of carbon and silicate don't float freely. They respond to the galaxy's magnetic field. These invisible lines thread through the Milky Way, steering charged particles and subtly organizing gas and dust. In some regions, dust grains spin rapidly and glow faintly in microwave light. Elsewhere, they align with magnetic fields, polarizing the starlight that filters through them. By studying these patterns, astronomers can trace the galaxy's magnetic skeleton and refine measurements of the cosmic background. Dust is not still, it follows a hidden choreography shaped by magnetism. Some stars are marked by the aftermath of neutron star collisions. When two neutron stars merge, the explosion, a kilonova, creates some of the universe's rarest heavy elements: gold, platinum, uranium. These materials disperse into space, seed future star forming clouds, and become part of new stellar generations. Certain stars in the Milky Way carry this signature. Their atmospheres are rich in elements that could only have been forged in these violent encounters. They shine not only with light, but with the memories of ancient cosmic alchemy. The Milky Way may contain a bar within a bar. Our galaxy's center holds a long bar of stars stretching through the bulge. But deep inside that structure, astronomers have detected signs of a second smaller bar tilted differently and rotating on its own schedule. Dust hides it from direct view, but its gravitational fingerprint appears in the movement of stars and gas. Nested bars like this can channel material inward, slowly feeding the central black hole and sculpting the heart of the galaxy. The core is not a simple shape, but a layered, shifting maze of stellar motion. Gas flows into the Milky Way from the cosmic web. The galaxy is not sealed off, it breathes. Fresh gas filters in from the intergalactic medium, drawn along long filaments that stretch across cosmic space. These delicate streams provide the raw material for new stars, replacing what the galaxy expends over time. Some of this gas arrives cold, slipping quietly into the disk. Other inflows fall in hot, glowing in ultraviolet or X ray light as they slow and settle. These hidden rivers fuel the Milky Way's continued growth, linking it to the vast web of matter beyond. Even now, the Milky Way continues to draw from distant cosmic reservoirs, sustained by faint filaments of matter stretched across space since the universe was young. When clusters of massive stars explode, they carve enormous hollows in the interstellar medium. These cavities can merge into superbubbles, vast pockets of superheated gas that rise and punch through the galactic disk, opening chimneys into the halo. Through these channels, energy enriched material and magnetic fields escape upward, allowing the galaxy to vent and regulate its internal pressure. In this way, the Milky Way breathes not only across its disk, but also through towering columns that carry its heat and heavy elements into the dark. The galaxy also shines intensely in wavelengths we cannot see. Though it appears calm in visible light, the Milky Way glows fiercely in X rays. Collapsed stars, black holes, and neutron stars in binary systems pull in gas that heats to millions of degrees. Even the halo holds thin veils of hot gas emitting faint X ray light. With telescopes like Chandra and XMM Newton, astronomers see a galaxy that is anything but quiet, one filled with extreme temperatures, compact remnants, and hidden radiation woven through its structure. Pulsars act as the galaxy's precision clocks. When a massive star collapses into a neutron star, it may be left spinning with beams of radiation sweeping space like a lighthouse. These pulsars can rotate hundreds of times each second, their pulses arriving with astonishing regularity. They serve as cosmic metronomes, used to measure distances, test gravity, and even hunt for gravitational waves. Across the Milky Way, these remnants blink steadily, born from destruction, yet keeping time with remarkable order. Radio waves reveal the hidden skeleton of the galaxy. Much of the Milky Way is concealed by dust or distance, but radio waves slip through the darkness. They map cold hydrogen outline magnetic fields and trace emissions from pulsars, supernova remnants, and far off quasars. With giant radio telescope arrays, astronomers chart the spiral arms, measure the disk's warp, and find star forming regions invisible to the naked eye. Where light cannot pass, radio wavelengths uncover the shapes that lie beneath. The galaxy speaks in a frequency our ears can't hear, but science can translate. The Sun almost certainly began life in a stellar cluster. Stars rarely emerge alone, they form in groups from the same collapsing cloud. Our Sun once shared its birthplace with hundreds or even thousands of siblings. Over time, gravitational tides and the galaxy's motion pulled that cluster apart, scattering its stars across the Milky Way. Most of those siblings now wander far from us, faint and lost among billions of others, carrying only subtle chemical traces of their shared origin. Today, astronomers search for those long lost relatives. Using Gaia's precise motions and spectroscopic surveys, researchers hope to identify stars that match the sun's chemical fingerprint and age. A few promising candidates have already appeared, possible siblings scattered through the galactic disk. If confirmed, they could reveal the conditions in which the early solar system took shape. Our place in the galaxy may not be as solitary as it seems. Somewhere out there, members of the sun's original family may still be shining. And throughout all this motion, even the galactic disk itself does not remain perfectly still. As it rotates, the Milky Way's disk wobbles, flexing gently, like a spinning plate with a slight imbalance. The outer regions bend upward on one side and dip downward on the other. This slow moving warp may arise from the pull of nearby dwarf galaxies, from dark matter interactions, or from ancient asymmetries in the disk's formation. The ripple moves gradually across the stars, a reminder that even on the largest scales, nothing in the galaxy is ever perfectly flat or perfectly still. From Earth, none of this motion is obvious. But from a distant vantage, the Milky Way is not a flawless spiral. It moves like a living sheet of stars, gently bending and lifting as it rotates. Galactic tides play a quiet but powerful role in shaping this motion. Much like the moon influences Earth's oceans, the immense gravity of the Milky Way tugs unevenly on anything within its reach. Star clusters, dwarf galaxies, and even ancient globular groups feel this pull. Over long stretches of time, these tidal forces stretch and thin them, drawing stars into long arcs that trail across the sky or slowly peeling them from their original orbits. Many of the delicate stellar streams discovered in recent surveys are the remains of such gradual unweavings, clusters pulled apart, thread by thread, small galaxies gently dismantled by the Milky Way's persistent gravity. Measuring the galaxy that performs this work is surprisingly difficult. You might expect that we would know the mass of our own home, but most of it lies in an unseen halo of dark matter that cannot be measured directly. Only a small fraction of the Milky Way's weight comes from the stars and gas we can observe. The rest is invisible structure inferred from the speeds of stars far from the center. Because these measurements are uncertain estimates of the Milky Way's total mass range, widely some near a trillion solar masses, others far higher. Even with modern instruments, the galaxy's true heft remains partly concealed, one of astronomy's quiet, lingering puzzles. This uncertainty extends to our comparison with Andromeda. For decades, astronomers assumed Andromeda must be more massive because it appears larger and brighter. Yet recent data hint that the Milky Way's dark matter halo may be broader and denser than once believed. If so, our galaxy could actually outweigh Andromeda. This isn't just a matter of pride. The mass ratio between the two spirals will influence how they fold together when they meet billions of years from now. The Milky Way may look serene from within, but beneath its graceful arms, it may carry far more gravitational authority than we once imagined. Even our closest companions may not be what they seem. The Large and Small Magellanic Clouds. Two brilliant satellite galaxies, visible from southern skies, were long believed to be long term orbiters of the Milky Way. But new measurements of their velocities suggest they might not be ancient companions at all. They may be recent arrivals captured only within the past few billion years. Their first close passage appears to have disturbed the Milky Way's outer disk, warping its shape and stirring its edges. It is as if the galaxy is adjusting to the influence of a new gravitational neighbor, responding slowly to a visitor just now falling under its sway. Trailing behind these galaxies is a long, ghostly ribbon of gas, the Magellanic Stream. Trailing behind the Magellanic Clouds is a long, ghost like river of hydrogen gas known as the Magellanic Stream. It stretches for hundreds of thousands of light years, curling in faint arcs across the southern sky. This immense ribbon was drawn out by tidal forces as the dwarf galaxies brushed past one another and drifted close to the Milky Way. Invisible in ordinary light, it appears only in radio wavelengths, a soft trailing signature of motion, separation, and slow unraveling. One day this stream may fall inward and help seed new stars in the Milky Way, or it may simply linger in the halo, a delicate thread linking galaxies across time. Not all gas follows the familiar plane of the disk. Some clouds, and even some stars, travel on steep, tilted orbits, looping high above and far below the galaxy's main structure. These polar paths are likely relics of earlier mergers when wandering dwarfs or stray clouds were captured at sharp angles and never fully aligned with the disk. They continue circling on these inclined tracks like long period comets around a planet. Each of these misaligned orbits is a quiet testimony of disturbance evidence that the Milky Way is open to encounters and shaped by the unpredictable currents of cosmic history. In various corners of the galaxy, astronomers have uncovered enormous spherical shells of gas vast bubbles spanning hundreds of light years. These structures are the echoes of ancient starbursts, times when clusters of massive stars were born together, lived briefly, and died in rapid sequence. Their fierce winds and supernova carved out immense hollows in the interstellar medium, pushing gas outward in all directions. Though the expansion slows over time, the shells remain ghostly bubbles, marking where the galaxy once erupted with concentrated creation and destruction, fossils of stellar fireworks still lingering in the cold. Even though space is overwhelmingly vast, stars can occasionally collide in the densest environments of the Milky Way, especially in the tightly packed cores of globular clusters. When two stars meet, the result can be spectacular: a flash of energy, a merged star, or the creation of a rare blue straggler that looks strangely young among its ancient neighbors. Such collisions are uncommon, but across billions of years, gravitational jostling makes them inevitable in these crowded stellar cities where space is anything but empty. Many stars exist in pairs circling each other in a delicate gravitational dance, but even these partnerships can be broken. A binary system that strays too close to the supermassive black hole at the galaxy's center or through a dense stellar cluster can be torn apart by tidal forces. One star may be hurled outward at high speed, while the other is drawn inward or left behind. In some rare encounters, a companion star is flung away with such force that it escapes not just its partner, but the Milky Way itself, launched into the vast intergalactic dark as a solitary wanderer. These quiet stellar separations happen far from our view, ancient bonds pulled apart by gravity's shifting hand. Most stars remain bound to the Milky Way, but a small number manage to reach escape velocity over 500 kilometers per second and slip free forever. These hypervelocity stars, though uncommon, are real. Some are thought to be launched by interactions with the supermassive black hole in the galactic center. Others are ejected through chaotic three-body encounters or by a supernova disrupting a binary pair. Once liberated, they drift alone beyond the spiral's edge, like tiny lanterns moving into the deeper dark, carrying with them a trace of where they once belonged. Not every star in our galaxy was born here. A fraction of them formed in other systems, captured during ancient mergers, or nudged into our halo from elsewhere in the local group. These foreign stars often travel on unusual paths, far from the disk, and can be identified by their compositions or motions that don't match their neighbors. They are cosmic travelers, remnants of other environments and other histories woven into the Milky Way's ever-growing tapestry. Our galaxy is not closed. It is an ongoing gathering assembled piece by piece over billions of years. Above and below the bright disk, gas rises and falls in a looping cycle known as the galactic fountain. Supernova explosions and stellar winds push hot gas upward into the halo. There, it cools, slowly condensing until it settles back toward the disk again. The circulation mixes, the interstellar medium spreads heavy elements, and moderates the pace of star formation. It is a quiet, breathing motion matter, lifted, released, and returned a subtle rhythm that keeps the galaxy evolving over immense stretches of time. Within drifting interstellar dust, grains astronomers have found complex organic molecules. Carbon-based compounds, such as simple sugars, alcohols, and polycyclic aromatic hydrocarbons. Though not alive, these molecules form the starting chemistry upon which life can later build. Created in the atmospheres of dying stars, or in the cool dark of molecular clouds, they travel across the galaxy on tiny dust particles. Some of this dust likely fell onto the early Earth. Far from being mere debris, these grains carry potential microscopic cargo moving silently through the void. The same clouds that form stars also seed planetary systems. As a cloud collapses into a newborn star, the surrounding disk inherits its chemical makeup. If that cloud is rich in water, carbon compounds, or prebiotic ingredients, those materials become part of comets, asteroids, and eventually planets. Certain regions of the Milky Way contain especially abundant prebiotic chemistry. Whether life is common or rare, the ingredients appear to arise naturally, scattered throughout the coldest corners of the galaxy, waiting for worlds to gather them. Most stars spin, but some rotate astonishingly fast, whirling around in mere hours. These rapid rotators tend to be young and massive, their equators bulging outward from extreme centrifugal force. A few spin so quickly that they shed material into glowing disks around them. By comparison, the sun takes nearly a month to turn once. These fast spinning stars live intense, short lives, spinning like bright beacons before they burn out. From Earth, the Milky Way sweeps across the sky at a striking angle because its plane is tilted relative to the ecliptic, the flat path traced by Earth and the other planets around the Sun. The galaxy's disk is inclined by about 60 degrees, causing its glowing band to rise diagonally and shift position with the seasons. This tilt shapes the way we see our home galaxy, turning its luminous arc into a seasonal companion across the night. We are part of the galaxy, yet our little solar neighborhood sits at a slight angle, a small tilted vessel drifting across a much larger rotating sea of stars. Some stellar remnants reveal ages that reach back even further than the galaxy's thin disk. In the faint halo, astronomers have found ancient white dwarfs cooling stellar cores left behind by long dead suns that existed before the Milky Way's disk had fully formed. These relics come from a younger, wilder era when the galaxy was still gathering itself from collapsing clouds and early mergers. They have been cooling for billions of years, fading slowly, carrying memories of a time when the Milky Way was only beginning to take shape. The disk shines brightly, but the halo remembers farther back. Far beyond the spiral arms, the galaxy's outermost stars trace enormous orbits, drifting through the halo on paths so wide they take billions of years to complete. Some were stolen from smaller galaxies long ago, now wandering the outskirts like distant sentinels marking the galaxy's true reach. They are dim, solitary, and widely spaced, but their motions reveal the Milky Way's true size and gravitational pull. The galaxy is far larger than the glowing band we see stretching deep into darkness, where these wanderers keep silent watch. Despite popular images, the Milky Way is not perfectly even. Its disk is thicker on one side. Some spiral arms glow brighter or stretch farther, and even the halo sits slightly off center. These subtle distortions likely come from past encounters with the Magellanic Clouds, with clumps of dark matter, or with galaxies torn apart long before humans existed. Instead of a flawless pinwheel, our galaxy is a living shape, molded by nudges and collisions, more like a spinning dancer whose flowing skirt has been caught by shifting winds. Its beauty lies in that asymmetry, an elegant imbalance sculpted by time. To chart this vast form, astronomers rely on special stars whose brightness rises and falls in steady rhythms. These variable stars, Cepheids RR Lyrae, and others pulse with predictable patterns. The period of their pulse reveals their true luminosity, and comparing that to their apparent brightness reveals their distance. Scattered throughout the Milky Way, like luminous heartbeat markers, they allow astronomers to measure the galaxy's depth, trace its arms, and uncover its hidden structure. They are cosmic rulers, blinking beacons that turn darkness into a map. And above Earth, a quiet spacecraft is transforming everything we know. The Gaia mission, launched by the European Space Agency, is building the most detailed portrait of the Milky Way ever attempted. By recording the positions, motions, and colors of more than 2 billion stars, Gaia has revealed streams left by shredded galaxies, mapped the disk's gentle warp, and traced the sun's orbit with remarkable precision. Each new release sharpens our view, turning a blurred smear into a rich, dynamic three-dimensional world. It is the most ambitious star atlas in human history. On a clear night, that atlas becomes visible to the naked eye as a pale river stretched across the sky. This is the galactic plane, the densest slice of the Milky Way's disk. From our position within it, we look sideways through its crowded layers. Stars pile upon stars, dust clouds overlap, and nurseries glow behind veils of darkness. This bright band is not a simple line, but a deep corridor, the most populated region of the galaxy. When we look into it, we're staring along the grain of our cosmic home, peering through the richest region of our spiral world. This glowing band across the night isn't just beautiful, it's the dense, humming heartland where most stars are born, live out their long, bright lives, and eventually fade. And if you follow that glow toward the constellation Sagittarius, the sky grows richer, heavier with light. That direction points to the Milky Way's core, a crowded concentration of stars, dust, and unseen mass. Invisible light, we can't peer through the thick curtains of dust that hide the very center, but infrared and radio observations reveal a region blazing with activity. Even to the unaided eye, that portion of the sky feels fuller, the starlight layered and overlapping, a soft shimmer made from billions of suns. We orbit far from that energetic center, tucked into a quieter suburb of the galactic disk. But when we turn our gaze inward, we're catching a glimpse of the galaxy's bustling capital, brilliant, ancient, and impossibly dense. And because we live inside this spiral system, our view of it is unlike the diagrams you may have seen. We cannot look down upon the Milky Way from above. Instead, from Earth, the galaxy appears as a flattened river of light stretching across the darkness, an unbroken arc shaped only by the curve of the horizon. This inside out vantage point compresses the entire structure into a single luminous sweep, making its true form difficult to imagine. It took centuries of careful measurements, catalogs, and patient deduction before humanity understood the kind of galaxy we inhabit. From our place in the disk, we look along its length like a traveler standing deep within a forest, seeing only the trunks ahead, never the full shape of the woods. Even with all our telescopes and instruments, the Milky Way keeps most of itself hidden. Dust blocks light, distance blurs detail, motions unfold too slowly for human lifetimes. Dark matter, which outweighs all the visible stars, reveals itself only through gravity. Between each point of light spans emptiness, and within that emptiness lies the potential for new worlds, new stars, new stories. The Milky Way is far more than the fragile glow we see. It is a vast collection of what we can observe, what we can infer, and what still remains beyond our reach. It holds ancient starlight and seeds of future suns, drifting planets, and remnants of forgotten fusions mysteries woven into every layer of its structure. And within that boundless sweep here, we are a single world orbiting an ordinary star, moving gently through a narrative so large the human eye can barely hold a piece of it. Now the stars begin to fade behind your thoughts. We've wandered together through so many quiet truths tonight, from the bending of the galactic disk to the lonely stars in the far halo, from fiery stellar births to the cooling embers of long dead giants. You've drifted through nurseries of gas and dust, glided along spiral arms, and peered toward the hidden glow at the galaxy's core. You belong to this place. You're not merely traveling through the Milky Way, you're made from it. The iron in your blood was forged in ancient stellar hearts. The oxygen in your lungs was sculpted by explosions older than the earth itself. Every atom in you has journeyed through stars, through clouds, through time, carried forward from the earliest ages of the universe. And as you settle into rest, the galaxy continues its quiet turning. New stars ignite. Light travels between worlds. Orbits proceed in perfect silence, and you drift within that rhythm, a small warm presence in the dark, resting inside a spiral arm of this wide and radiant sea. If your eyes are still open, you're welcome to slip into the next chapter whenever you like. For now, may your night be gentle and your dreams soft. Good night.